6C, we're going to talk about geometric probabilities and the geometric distribution. So similar to binomial distribution, which is what we've been talking about, it's just got a little tiny difference in the rules, which changes how we calculate things. Okay, so there are three characteristics of a geometric distribution. The first is that trials are repeated until a success is achieved. Okay, so if, for example, I was going to shoot free throws, all right, I would shoot until I made one. And then as soon as I made one, I had a success, I would stop. And then X is the number of trials that takes. How many shots did I have to take until I actually made one? Okay. Second requirement is there's only two possible outcomes, success or failure. In this case, it would be a make or a miss. Right? And then just like with the binomial, P and Q are the probability of success and failure. And then finally, the trials are independent and conducted using identical conditions. Okay. So I'm shooting at the same basket every time. It's always me shooting. I'm not switching off with another person. Okay. So we got some formulas to look at. First one is for mean and standard deviation. Okay, so this is very similar to what we did with binomials. The mean is the expected value or the average number of trials it would take to get a success. Okay, so how many shots, if I was going to do this over and over and over again, how many times would it take me to shoot until I actually made one? Okay, and then standard deviation, of course, is a measure of how spread out that data would be. Okay, so we'll look at, as an example, our made-up statistic that I wish was true. 70% of stat students turn their practice problems in on time. If you randomly select students, X is the number of students you must ask to find one who has turned their practice on time. Okay, so if I just randomly pick some of you guys, did you do it on time? Yes or no? Did you do it on time? Yes or no? How many people would I have to ask to find someone that had actually done it on time? Okay, so first question we have to decide, is this a geometric distribution? Does it meet our three qualities? Am I repeating trials until I get a success? Yes. All right, are there only two outcomes, success or failure? Yes, either you did it or you didn't on time. And then are the trials independent? Yes, each of you are individuals who make your own decisions, so we meet all three requirements. Yes, this is a geometric distribution. What is the value of P? The probability of success for any individual student is 0.7 because 70% of you do it on time. So now let's find the mean and the standard deviation. Okay, so the mean, that formula is going to be 1 over P. Okay, so 1 over 0.70, and if we do that math, that is equal to 1.43, round to the nearest whole number, so approximately 1. Okay, so it would take me approximately 1%. So the first person, there's a good chance that the first person that I ask would be someone who had done their stats or their practice problems on time. Okay, and then the standard deviation, that formula, okay, is the square root of 1 over P times 1 over P minus 1. If I were you guys, since we're going to use Desmos for the binomials, I would go ahead and use the Desmos calculator because you can type this all in exactly as it's written and don't have to worry about all the crazy parentheses that you would need in a handheld calculator. So this number should be 0.78, or again, rounded to the nearest whole number, that is approximately 1. Okay, so that is the mean and the standard deviation. All right, what does this mean in the context of the problem? I would ask an average of one person, all right, to be able to get the a person that said yes. And the standard deviation there would also be around 1. Okay, and then just like we did with binomials, we are going to look at probabilities. Okay, so 3 different kinds of probabilities: exactly, less than, at least, just like we did with the binomials. All right, this time, however, Desmos doesn't have a geometric distribution, so we're going to use formulas. All right, but they're not too complicated, so should be pretty easy to plug in. All right, so the probability of asking exactly 12 students before someone did it on time. Okay, here's my formula. So for all of these things, you're going to want to know what P is and what Q is. All right, so P was the probability of success, so that was 0.7. Q, remember, is 1 minus P. All right, so if there's a 70% chance of success, then there's a 30% chance of failure. Okay, so the probability that I would ask a bunch of students and it would take me 12 people until I got someone that did it on time, that would be 0.3 to the n minus 1, and n is the number that they give you. So 12 minus 1, and then we're going to multiply that by p, which is 0.7, and we're going to put that in the calculator all together. All right, so when I put this in Desmos, I get a teeny tiny number. So let's see, 1, 2, 3, 4, 5. 5 zeros, and then 1, 2. Okay, and if we think about it, that makes sense. If the average number of people that I would have to ask would be 1, then getting all the way up to 12 would be highly unlikely. Okay, now we have the probability of asking less than 12 students. Okay, and so here's my formula. So 1 minus Q, which is 0.3, to the n minus 1. All right, so 1 minus 0.3 to the 11th is what that ends up being. Okay, and so I'm in Desmos doing that math. 1 minus 0.3 to the 11th is 0.9999999, or approximately 1. Okay, which that makes sense, right? If I have this teeny tiny number for getting 12, then the chances of me being less than 12 are really, really high. Okay, and then the last one is the probability of asking at least 12 students before someone did it on time. Okay, so here's my formula, Q to the n minus 1. Okay, so Q is 0.3 to the 12 minus 1, or n, which is 0.3 to the 11th power. Okay, and that's also a teeny tiny number. Let me count these zeros. 1, 2, 3, 4, 5. That's 5 zeros again. And then 1, 8 rounded. Okay. And again, this makes sense, right? The probability of me asking 12 or more people before finding someone that did it on time when the probability of success is 70% is pretty low. Okay, one thing that I want you to notice is that the probability that greater than or equal to, the probability of at least, and the probability of less than are opposites of each other. So 1 minus, okay? And if you think about it, that makes sense because the probability of asking at least, if I have my options, I have 0 to, I don't know, we'll say there's 100 students, okay? At least 12 would be 12 or more, so that would be all of those probabilities. And then less than 12 would be these probabilities. And so remember, all of the possible outcomes that can happen, they always have to equal 1. Okay, so that's why the probability of less than is 1 minus the probability of at least. Okay, if you were to Google how to do part 2, the probability of asking less than 12 students, it's going to have you calculating individual probabilities for all the numbers from 0 to 12 and then adding them up. I don't think you want to do that. It's annoying, especially if our number as big as 12, you would have to find 11 different probabilities and add them together. So if I were you, this is the method that I would use. Okay, and that is it for 6C.